All right, so today's stuff, it's more like a review if you have taken physics or if you are taking physics. Anyone who took physics last year? Anyone who is taking physics right now? Anyone who did not take physics at all? Okay, that's pretty smart. Oh, you take it next year? Okay, all right. Now, and the thing that we do here, it's very simple. And if you have taken physics already, then you know what's going to happen. If you did not take physics yet, then it's like a little preview, great preview. It's very simple. So we have something called a vector. Now in physics, you learn something called a vector, something's a scalar. What's a scalar?
A quantity that only has a magnitude.
Only magnitude, right? Quantity only has a magnitude, no direction ever. That would be a scalar, and a vector would be something with a magnitude and a direction. Okay. So when you indicate a vector, and in physics, you talk about velocity, you talk about acceleration, you talk about forces. Those are all vectors. Okay. And the way we indicate a vector is simply using an arrow. Okay, where it starts and where it ends, we point to whatever direction that it's going to be, and the length of the vector is relative to its magnitude. A big magnitude would be a long vector. A small magnitude vector would be a small short vector. And the way we connect. Now, this is the key thing here. How many of you still remember about head to tail method of connecting vectors? I think this is like a must. Okay, who has been through the physics course? So all vectors must be connected from head to tail. All vectors must be connected from head to tail. We're talking about the individual vectors. They must be connected from head to tail. So that would be a good example. There will be a good example here. Now, on this diagram, we are going to draw something here that's called this is a resultant vector. Okay, this is a resultant vector. So this is not the individual vector. So we're not doing the head to tail for this one. This is a resultant indicating where it starts and where it ends. Where it starts and where it ends. And to indicate a vector, we always put the little arrow on top of the letter to indicate that, hey, this thing right there is not a variable. It's actually a vector. So now, what if you have two vectors what if you have two vectors like this? What do? Well, if you have two vectors like this, so what you do is to go ahead, draw an identical vector, and put it right here, so that you can draw a resultant vector like this. Okay. Now, it doesn't really matter which one you move or which one you duplicate, as long as you duplicate one of them and then you draw the one with the same magnitude. So you can also do this if you want to. You can duplicate the horizontal vector, and either way, you will form a parallelogram. Either way, you will have the same resultant vector. Either way, you have the same resultant vector. So now, in physics, and because it was taught in the very early stage of your physics course, and you didn't learn much, you didn't learn many tools to handle these calculations. So what you probably would do to find out the resultant is that you will have the x component, the y component. If it's slanted like this one, you will have to break it down to both x and y components first. You add them all together and then use Pythagorean theorem to find out the resultant. And that is a lot of work. But based on what we have learned right now, we can do something easier. So we can say, let's look at this one right here. So Joe and Yank are pulling up a tree stump. Joe can pull with a force of 160 pounds and Yank with a force of 145 pounds. All right, they pull at an angle of 24 to each other. Okay, so now, I'm going to draw the initial picture first. So this is considered the tree stump. So let's just say this is vector J for Joe, which is 160 pounds. And then you have another force that's 145 pounds, like this. That is vector Y, and this degree is 24 degrees. So this is just to portray what's happening in reality. All right, you have a tree stump, two guys are pulling, okay, with a great deal of force. Let me write down the force here as well. This is 145 pounds. Okay, that's the force. And with an angle of 24 degrees. Now, however, these two vectors are not connected from head to tail. So that would not be the diagram we are working with. Eventually, we have to transform this diagram a little bit. So we say, all right, so we're going to draw another diagram to show how these vectors are connected together. Okay, so this is the vector Y, which is 145 pounds. All right, so let's draw the picture here first. So again, we've got to connect the vectors together from head to tail. From head to tail. And we would like to find out the overall resultant vector. Thank you. Hold on. Okay, so all right, now, so with the tools that you have just learned, how can we find out the magnitude? And by the way, when we express magnitude, this is how we express it. It's like an absolute value, but with an extra stroke. That's how we express the magnitude of a vector. So how do we find out the magnitude of this vector R using what we have just learned recently? Louder? Yeah. So if you know the angle here is 24 degrees, that means the other angle must be 156 degrees. And since you have the length of two sides, you want to find the length of the third side, and you have one angle, hey, guess what? That's your law of cosine right there, okay? So so it would be this R squared is equal to 160 squared plus 145 squared, and then minus 2 times 160 times 145 times cosine of 156. So I'm going to do this here. My calculator, 160 square plus 145 square, oops, square minus 2 times 160 times 145 times cosine of 156. And then all being square rooted. So the magnitude of the vector is simply 298.35 pounds. Okay. So now with our new tool, we can actually find out these magnitudes a lot easier compared to what you have learned in physics, for those who have taken physics already. Okay. We do not need to break down the x components or the y components. We can just take the vector magnitude and find out the angle, and we can get the resultant vector straight away. So if you are taking the AP exam, how many of you are taking AP physics exam this May? One? Just one? Wow. Okay. Well, then make sure that you don't forget about the law of sine or law of cosine. It would be very helpful for you to find out these resultant vectors. Okay, so just something right here. Now, here, for the one that's down below, yes. We say, please find the magnitude of the vector that's drawn. So we're going to label it right here. So we say, hey, what is the magnitude of this vector u? U. Well, can you tell right away? What is the magnitude? Well, if you draw out the triangle right here, you will see that it's a 3, 4, 5 triangle. So, I mean, we can use Pythagorean theorem, but since we recognize that it's a 3, 4, 5 triangle, you can just say it's 5. Okay, find the direction vector and then find the magnitude of it. Okay, now the direction. Now this one is a little bit challenging, just a little bit challenging. We would like to know what's the angle here. We would like to know what's the angle right here. Okay, and how can we find out the angle? We can do, well, we have 3, we have 4, and we have 5. So we can just do sine theta, it's equal to 3 over 5. And then we can find out what theta is. So we do inverse of 3 over inverse sine of 3 over 5. And that's equal to 36.9 degrees. Okay. 36.9 degrees. Okay, so find the direction vector and find the magnitude of it. So that's pretty much it. Okay, so what we will write down here is, oh, we don't even need that. Okay, now, so let's go ahead and write this down. So for direction vector, this is how we express it. Okay, for direction vector, we express it as, with this arrow bracket, we'll say 4, 3. Okay, we'll say, oh yeah, it's moving to the right 4 units and up 3 units. Okay, moving to the right 4 units and up 3 units. That's how we write down our direction vector. Okay. So yeah, so that's how we draw it. And when we try to do the direction vector, I want you to draw the direction vector too, and that is we tend to draw the vectors, direction vector from the origin. So you would basically replicate this vector, but you start from the origin. So that's your direction vector right there. Okay. Four, comma, 3. And then the one on the right, you can see that the V vector, it's going to the left 2 units and up 4 units. Okay, left 2 units and up 4 units, so you can get the vector straight away. If you want to find out the magnitude, okay, so just go ahead and use the Pythagorean Theorem to find out 2 square or negative 2 square plus 4 squared, the whole square root. So you have 4 plus 16, which is square root of 20. So 2 root 5, it's the magnitude here. Okay, 2 root 5 is the magnitude here. So that's the direction vector and also the magnitude of the vector itself. Okay, so now let me give you some preview. Okay, in calculus, when do you actually see vector? It's gonna be a while. It's gonna be a while in calculus that you will see vector again. You will see vector in the beginning of calculus 3 course. Okay, so typically we separate the calculus into 3 courses: calculus 1, 2, and 3. Usually calculus 2 is the hardest one. Usually calculus 3 is actually easier than calculus 2. That's the general opinion, which I agree. Okay. Yeah. Calculus 3 is what we call the multi-variable calculus. That's where you start to explore different kind of planes and shapes and 3D objects, and it's so cool in 3D shapes. But Calc 2, it's a bit challenging. Okay, so vectors will be something that you will learn in Calculus 3. Okay. All right, let's go ahead to the next page. So now you have 3 vectors here. You have 3 vectors here, showing you here. Okay. And we say draw the vectors represented and the resultant, and find the magnitude of the resultant, find the direction vector, draw them, and then find the magnitude of the resultant algebraically. Now, it's very simple here. Okay, so I'm going to highlight a couple of situations. If you add the vectors together, so basically just join them together from head to tail. That's easy. Now, what if, like right here, there's a 2 in front of the vector v? What does it mean when there's a 2 sitting in front of the vector v? Anybody? If there's a 2 multiplied by the vector v, that means the vector, it's going to be twice as long. Same direction, but it's going to be twice as long. So 2v would be like going 4 units to the left and then 8 units all the way to the top. Okay. And now there's a minus u. What does the minus do to the vector? Oh, sorry, hold on. If you look at still part 2, it's yeah, if you look at this minus u, how does it affect the vector if there's a minus? So this is the regular u vector, and if it's a minus u, that means this vector will be opposite direction. Okay, so negative means opposite direction. Okay, so plus just means you join them together. If you have a number multiplied to it, that means the vector's length would change accordingly. If it's a 2, then you double it. If it's a 3, you triple it. Okay. If it's a minus in front of the vector, that means it changes its direction. So u plus v. So u is, let's go ahead and draw this. 3 moving 3 units to the right. No, 3 units up, 4 units right. So this is u. And then v, it's 2 units to the left and 4 units up. So this is your vector v. So so the resultant will be somewhere right here. That's your resultant vector. And in this case, the resultant vector, it's going to be, what is it? 3 to the right. And how many units up? 7 units up. Okay, so 3 comma 7, it's the resultant. And then if we want to find out the magnitude of the resultant, we will need to use the Pythagorean theorem. So 3 squared plus 7 squared, we get a square root of 58. No, 53, sorry. 50, no, 50. Wait, hold on. Did I draw something wrong? Oh, yes, I did. My bad. My u got wrong. Let me draw again. U is 3 units up and 4 units. Okay, so right here. This is the u. And then v is 2 units back to the left and 4 units up. Okay. No wonder. There should be a 2. Sorry. This is v. So your resultant, it's going to be like this. Okay, so this is a 50 square root of 53. Okay. All right, go ahead, take a moment. Okay, I want you to try out the next 2. Okay, try out the bottom 2. How would you draw 2v minus u, and how would you draw v plus u plus w? Okay, so go ahead, try it out. Give you 2 minutes. Okay, so we have 2v minus u. Now, what I can do here is to write out the direction vector for v, which is minus 2 comma 4. And then u vector, it's 4 comma 3. I think that would help me out here. So 2v means you have to multiply those vectors by 2. So you start from the origin, and instead of going to the left 2 units, you go to the left for 4 units, and then up 8 units. So 1, 2, 3, 4, 5, 6, 7, 8 right here. So that will be your 2v. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Okay, all right. And then with the u, it's supposed to be 4 comma 3. Okay, move to the right and up 3. But now with the negative u, you will have to move to the left 4 units and down 3 units. Right here. Left 4 units and down 3 units. That's your negative u. And then your resultant vector, it's here. So so in this case, this is without the degrees, without the angles. So this is like what you have done in physics. So you're basically counting like, okay, what's the resultant vector? The resultant vector is moving to the left for how many units? For a total of 8 units to the left and up by 5 units. Okay. And with that, you will find the magnitude, okay, by doing the Pythagorean theorem. So you have 64 plus 25. 64 plus 25, it's 89. Okay, so square root of 89 is the magnitude of your resultant vector right here. Okay. And now we're gonna have the W here as well. W is very simple. It's just moving to the right for 3 units. Okay, W is moving to the right for 3 units. So we just have to draw all the vectors here. So -2, 4. It's right here. That would be your V vector. And then your U vector, it's 4, 3. So 4 units to the right, 3 units up. That's your U vector. And then you have the W vector, and that is 3 units right, 0 up or down. So this is your W vector. And now you can join them together with from the beginning to the end. So we say, so the resultant vector here, it's going to be moving to the right how many units? You can see 5 units to the right, and then 7 units to the top. So the resultant vector's magnitude, it's going to be 5 square plus 40, plus 7 square. That is a 74. Under the square root of 74 is the magnitude here. Okay, so easy. Okay, so today's stuff is pretty straightforward. Okay, so just review of physics stuff, joining the vectors from head to tail, and even if you have not taken physics yet, this should not be anything too challenging. Okay, so it's very straightforward. So if you look at the worksheet page, so you have a bunch of vectors to draw, and then you also have two word problems, just like the one that we did, and chances are you're going to use the law of cosines to find out the resultant. Okay, so take the time right now to finish the worksheet so they don't have to work it at home.